Welcome to Chemistry Online. Today we're going to talk about balancing simple chemical equations. Remember, a chemical change can be described by a chemical reaction. In this case, we have aluminum reacting with bromine to give aluminum bromide. If we look at the equation that we have here, we have two atoms of aluminum on this side. We have 6 atoms of bromine and 6 bromines here. The arrow in a chemical equation has the same properties as an equal sign, so we must have the same numbers and types of atoms on both sides. In order to take an equation and to make it so that it does balance like this, we insert these coefficients. The coefficients describe the stoichiometry of the reaction. That is, the number of moles of each reactant and the number of moles of product. You'll note that we could also describe moles in terms of mass. 2 moles of aluminum is the same as 53.96 grams of aluminum. The same thing with bromine, and 533 grams of aluminum bromide is the same as 2 moles. The mass of reactants must also equal the mass of the products. Now, if you're given an equation and it's not balanced, what you have to do is simply insert numeric coefficients so that it winds up with the same numbers and types of atoms on both sides. Here we have the decomposition of hydrogen peroxide. We have 2 atoms of oxygen on this side, and we have 1, 2, 3 atoms on this side. In order to make this balance, a simple way to do it is to try to take the fact that this is odd, and this side is even, and fix that by inserting a coefficient to make it even on both sides. We can do that simply by putting a 2 in front of our water, so now we have 4 waters, and again it's even on both sides. We've also introduced 4 hydrogens here. We only have 2 hydrogens on this side, but we could fix that by putting in the coefficient 2. We now have 4 hydrogens, 4 oxygens on this side, 4 oxygens, 4 hydrogens on this side, and our equation is balanced. A simple problem. Potassium chlorate decomposes to give oxygen gas and potassium chloride. We write our simple equation like this. Once again, we have an odd number of oxygens here and an even number here. One strategy is to simply say, okay, well, we have 3 and we have 2. If we multiply the 2 together, we get 6. So let's fix this so we have 6 atoms of oxygen on both sides. We start off with 2 potassium chlorates, and we get 3 molecular oxygens. Now we've also introduced 2 potassiums and 2 chlorines, so we need a 2 on this side. This equation is now balanced. Let's look at some problems. In our first one here, we have 3 hydrogens, we have 2 hydrogens. We're going to have to double the number of molecules of ammonia. That's good because we have N2 on this side. In order to give us 6 hydrogens here, we're going to have 3 moles of hydrogen on this side, and that is the balanced equation. We have 1 hydrogen. Here we have 2. We're going to have to double the moles of HCl. Gives us 2 chlorines, but we need 2 chlorines, and that's all we have to do. In this one, it's a little more complicated. We have 3 oxygens here. We have 2 here. So we're going to double the number of iron 3 oxides. That's going to give us 3 moles of oxygen on this side. We're going to wind up with 4 moles of iron 3 chloride, and in order to do that, we need 6 moles of chlorine. We have 3 hydrogens on this side. We have 2 here, so we're going to have to double the number of moles of sodium hydroxide. Means we need 2 sodiums. We have 1 hydrogen, we have 2. We're going to have to double the HCl. We have 1 nitrate here, we have 2 on this side, so we need 2 silver nitrates. Our magnesium looks like it turns out okay, but we put in 2 silvers here, so we need 2 silver chlorides, and I think that works. One more simple set. Here we have ammonia with 3 hydrogens. Here we have hydrogen, H2, and another 2 hydrogens in sodium amide. We're going to have to double this in order to make it even. When we do that, we're going to introduce 2 nitrogens, so we need 2 ammonias. We also have double the number of sodiums. I think that something like this should work. 4 oxygens, 3 oxygens, we need to double this. 2 sulfurs, we have to double this guy. And finally, N2O5 plus water to give nitric acid. We have 2 hydrogens, we have 1, so we have to double this. We have 2 nitrogens, so that's good. I think it works out just like that. There's a tutorial for balancing equations. In the tutorial, you actually type in coefficients. Again, you must use the number 1 if there's only 1 mole. But in this case, we don't. Here we have ethene reacting with oxygen to give CO2 and water. We have 2 carbons, so we're going to need 2 carbon dioxides. We have 4 hydrogens, so we're going to need 2 moles of water. If you add up how many oxygens we need in order to do this, it turns out we need 3 moles of oxygen. One more. Calcium carbide reacting with water to give acetylene and calcium hydroxide. We have 2 carbons, we have 2 carbons. That's good. 1 calcium, 1 calcium. We have 2 hydrogens, but 1 oxygen on this side, 2 on this side. We're going to have to double our waters, and I think that's all it takes.